Welcome back to the Sentinel series. Last time, we talked about the high-level framework, the why of building on the cloud. Well, today, we're getting physical. We are moving from the why to the where, and we're going to define the actual physical and logical boundaries for our applications.
So let's just kick things off with a pretty blunt question that every single cloud architect has to answer. Where does your application go to die? Yeah, it sounds a little dramatic, I know, but trust me, planning for failure is the absolute cornerstone of building any resilient system. Your answer to this question really determines whether a tiny glitch stays a tiny glitch or spirals into a full-blown catastrophe.
All right, so today, think of it like we're climbing a stairway to availability. We're going to start by defining what failure even means, then we'll look at the basic building blocks for resilience. From there, we'll scale way up to global architectures, check out how to bridge different cloud and on-prem worlds, and then finally, we'll bring it all home to help you choose the right strategy for your app.
Okay, first things first, we need to be on the same page. To talk strategically about resilience, we have to have a shared vocabulary. We've got to agree on what we mean by failure and what our plans are to survive it. And this is where two really key concepts come into play.
The first concept is a failure domain. I want you to think of this as a boundary. It could be as small as a single server rack or as big as an entire data center, which, by the way, Google Cloud calls a zone, or even an entire geographic region. It's basically any area where one single event, like a power outage or a fiber cut, can take a bunch of stuff down with it.
And that brings us right to the second concept, the deployment archetype. So if a failure domain is the place where things can go wrong, the deployment archetype is your actual plan for surviving it. It's the blueprint, your strategy for placing your application across one or more of these failure domains to make sure it stays alive when things inevitably break.
So let's see how these ideas actually build on each other, starting with the two most fundamental archetypes. You can think of these as the workhorses of cloud architecture. They cover the vast majority of scenarios you're ever going to run into. We're going to start with the simplest of all, the zonal archetype. This is as straightforward as it gets. Your entire application, your servers, your databases, the whole shebang, it all lives inside one single Google Cloud zone. Just picture putting all your eggs in one basket, or maybe more accurately, all your servers in one building.
Now this is where it gets really interesting, because we're translating an architectural choice into a hard number. For a zonal deployment, Google Cloud's infrastructure is designed to give you a target availability of 99.9%, or what we call 3 nines. That's our baseline.
So when is this actually a good idea? Well, it's perfect for things like dev and test environments where you're trying to keep costs down. It's also great for apps that aren't critical and can handle a bit of downtime. Or maybe you've got a batch job that needs all its computers right next to each other for super low latency. And sometimes, honestly, you're just forced into it by old-school software licensing.
Okay, but what if you need more? What if 99.9% isn't good enough? That is exactly where the regional archetype comes in. Now, we take our application and we deploy independent copies of it across multiple zones. So, multiple data centers, all within the same city, or what Google calls a region.
And just look at the power of that one change. By moving from one building to multiple buildings in the same city, the target availability of the infrastructure jumps an entire order of magnitude to 99.99%. That's 4 nines. That's a massive, massive leap in resilience.
This right here is why the regional archetype is really considered the gold standard for most production workloads. It's perfect for highly available applications that serve users in a specific area, just like our TradingMaster AI APIs. It also helps you check the box for those data sovereignty laws that say your data has to stay inside a certain country.
And here's the most important takeaway. With this setup, if one of those data centers, an entire zone, goes dark, your application just doesn't care. It doesn't skip a beat. Traffic automatically gets rerouted to the healthy zones. And if your data is being copied in real time across those zones, your recovery time is practically zero. The app just keeps on running.
So, regional is great, but what happens when highly available still isn't enough? What if you need to serve users all across the globe? Or what if you need to survive a disaster that could take out an entire geographic region? Well, for that, we have to start thinking a lot bigger. So the multi-regional archetype is our next big step up. With this, we're not just in multiple buildings in one city, now we're in multiple cities. We deploy full independent copies of our entire application in 2 or more completely different Google Cloud regions, say one in North America and another one over in Europe.
And by making that move, we finally reach what many people call the holy grail of availability, 5 nines, or 99.999%. We are now talking about a system that's designed to be down for just a few minutes over an entire year. This is the level you need for truly mission-critical global business.
This kind of architecture is designed to survive something catastrophic, like a natural disaster that takes an entire region offline. If that happens, traffic is just seamlessly routed to the other healthy regions. It also gives a huge performance boost to your global users because they're always being served from a data center that's physically closer to them.
And finally, we get to the top of the mountain, the global archetype. Now, this is a little different from multi-regional. Instead of having separate, redundant copies of your app, you actually architect it to run as a single, cohesive, globally distributed system. You're basically piggybacking on Google's own planet-spanning network and services.
So how does this magic actually work? Well, let's break it down. First, it all starts with a global Anycast load balancer. This thing is smart enough to automatically send every user to the healthy region that's closest to them. Then, your application itself is running across all those regions. But the real secret sauce, the magic ingredient, is often a globally consistent database like Cloud Spanner, which makes sure your data is always up to date and available, no matter where in the world you're looking at it from.
So far, we've pretty much stayed inside the cozy world of Google Cloud. But let's be real. Many organizations live in a much messier, more complex reality. And this final category of archetypes, the composite archetypes, they acknowledge that by building bridges out to other environments.
There are really two main flavors here. You've got hybrid, which is where you connect your own on-premises data centers to Google Cloud, and then you have multi-cloud, which is where you connect Google Cloud to another public cloud provider like an AWS or an Azure. It's a simple distinction, but a really important one. Hybrid is on-prem to cloud. Multi-cloud is cloud to cloud.
So why on earth would you go through all this extra complexity? Well, there are a bunch of really smart strategic reasons. You could use the cloud as a disaster recovery site for your on-prem systems. You could do what's called cloud bursting, where you send overflow traffic to the cloud when you get busy. Or maybe you want to beef up a legacy app with Google's awesome AI and ML services. And for some companies, it's the ultimate insurance policy, avoiding being locked into any single cloud provider.
Okay, we have covered a ton of ground, from a single data center all the way to a globe-spanning network. So now, let's bring it all together. How do you actually pick one? Well, the answer, as always, is about balancing the trade-offs.
This table right here is pretty much the key takeaway for this whole explainer. You can see the trends so clearly. As you move from left to right, your availability and your ability to withstand outages just skyrockets. A regional model shrugs off a zone outage, while multi-regional can survive an entire region failing. But, and this is a big but, look at those bottom rows. That resilience costs more and it's more complex to manage. You know, the most interesting thing on this whole chart might be that a true global architecture, while it's super complex to build, can sometimes actually be simpler to operate day to day because you manage it as one single system. So the crucial lesson is this: there is no single best archetype. There just isn't. The right choice for you depends completely on what your business needs for availability, for performance, and of course for cost. If you can align your archetype with your business needs, you've already won half the battle. Now, in our next explainer, we're going to build on this foundation and actually design the landing zone. Think of it as the secure, well-governed city where these archetypes get to live. Thanks for watching.